This video is going to introduce you to the law of cosines. The law of cosines is really just a formula that allows you to solve for sides and angles of triangles that are not right triangles. So in trigonometry, we were able to solve for sides and for angles using sine, cosine, and tangent, but those only worked with right triangles. This formula will let us solve for the sides of any triangles. Now I know this looks a little overwhelming with the 3 different formulas, but they're actually the same thing, just using different letters, and it just depends on how you label your own triangle. So in a second we'll look at how we label our triangles, but the important thing is that the little letters A, B, and C represent sides A, B, and C. The big letters A, B, or C represent angles A, B, and C. Notice that in the formula that starts with A squared, we have the cosine of angle A at the end. B squared, we have the cosine of angle B. C squared, we have the cosine of angle C. That's not a coincidence. Basically, whatever side we start with, we're going to be taking the cosine of the angle that's opposite it. So angle A is opposite side little a. Angle B is opposite side little b. Angle C is opposite side little c. So we start with one side, and then we're going to add the sum of the squares of the other sides, then subtract 2 times those same other sides, and then we tack on the cosine of the angle across from the original. Don't worry, it will make more sense the more you practice with it. Let's just quickly look at labeling sides. So again, it's never actually going to matter which side you call A, B, and C and which angle you call A, B, and C. The only important thing is that little a is across from big A. So let's say I call this angle A. That means this side over here has to be little a. If I call this here angle B, that means this side has to be little b. So that leaves here big C and little c. Let's actually see an example using the law of cosines to solve for a side. So in this example, we're given a triangle that is not a right triangle, and we're given a side, an angle, and a side. Notice that the angle is included between the 2 sides we know, and it looks like we're looking for the side opposite the known angle. So I'm just going to label my sides A, B, and C and my angles. We'll go angle A, angle B, angle C. Again, remember, it doesn't matter as long as I now label my sides appropriately. So 7's across from A, so that's little a. 11's across from C, so that's little c. And X is across from B, so that's little b. Now, notice that the only angle we know is angle B. So the only equation up here that's really going to help us is this middle equation, because that has the cosine of angle B. If we use any of the other equations, we're going to end up with 2 variables because we won't know the measure of angle A or angle C. So I'm just going to recopy my equation, b squared equals a squared plus c squared minus 2ac cosine of b. And now I'm just going to plug everything in. So b squared, well, that's the one I don't know, so that's x squared equals 7 squared plus 11 squared minus 2, 7, 11 cosine of 50. Now, really all I did was plug in. So a I replaced with 7 since I had labeled that as little a. Little c I replaced with 11. Same thing here, and then I plugged in my angle b for my b and the cosine. Now I'm just going to simplify some more. So I'll have x squared equals 49 plus 121 minus 2 times 7 times 11 is 154 times the cosine of 50. Now this is really important. Make sure you do this multiplication here first before you add and subtract anything. We're going to follow PEMDAS. So I just did that in my calculator, and I noticed that this whole thing became 99. It rounds up to actually exactly 99, so I'll just leave it as that. So now I have x squared equals 49 plus 121 minus 99. Using the calculator again, I get x squared equals 71. So x is going to equal the square root of 71, which is 8.42. So that was an example of a time that you know a side, an included angle, and another side. And you're looking for the last side. Let's do a slightly more difficult example where we're actually going to be looking for an angle. And in this example, they've already given us our A, B, and C. All we're left to do is put in our little letters. So 8 is little a, 6 is little b, and 7 will be little c. Now I notice that I'm looking for angle B. So I'm again actually same as the last one. I'm going to choose this middle version of my equation because it's the only one that has an angle B in it. These other ones would let me find angle A or angle C, but that's really not what I'm looking for, so that would not be as efficient. So I'm just going to recopy my equation. I have b squared equals a squared plus c squared minus 2ac cosine b. So I'm going to plug my stuff in now. B squared is 6 squared equals 8 squared plus 7 squared minus 2, 8, 7 cosine b. Simplify, 36 equals 64 plus 49 minus 112 cosine b. Now be really careful here. It's very tempting to just add up all these numbers. But notice this 112 is attached to the cosine of b. So we're going to have to leave that here by itself for a little while. But what I can do is subtract 64 and 49 from both sides. So what I'm left with is negative 80 on the left equals, so these went away, negative 112 cosine b. At this point I have to divide both sides by negative 112. So I'm left, and I'm going to come up here, I'm going to have 0.714 equals cosine of b. Now we're looking for an angle here, so I can find b using the inverse cosine. So b equals 44.4 degrees. So a question you might be asking yourself right now is when are we actually going to use the law of cosines? How do I know I want that rather than SOHCAHTOA or some other law? Well, the way you'll know is it's going to be a non-right triangle, and then you're going to be in one of two different situations. You're either going to be in an SAS situation, which means we know a side, occluded angle, and then another side, and we're looking for that final side. Or we're going to be in a side-side-side situation, so we know all three sides, and we're looking for some angle, any of them. So the side angle side was like example 1, the side-side-side was like example 2. So for homework, I'd like you to find in number 1, little a. So that's across from angle A, and that's going to be a lot like example 1, if you need to go back and watch it. And then in number 2, I want you to find theta when we know three sides, which is angle B. So that's a lot like example 2. Good luck.